What if the chemicals in our water, air, and even our blood aren't acting alone? That's the uncomfortable question now confronting Europe as it rethinks how to regulate thousands of industrial substances. The European Union's upcoming update to its REACH regulation, registration, evaluation, authorization and restriction of chemicals, has triggered fresh debate over how to manage what researchers call chemical cocktails. And this is the part most people miss. Even low-risk chemicals can become dangerous when mixed. Until now, chemical safety rules have treated every substance separately, as if none of them ever met in the environment. Each manufacturer must prove their product is safe, including its concentration levels in air, soil, or water. But in reality, our bodies and ecosystems don't encounter one chemical at a time. They face mixtures of dozens, sometimes hundreds, simultaneously. Take a sample of water or blood, explains Thomas Backhouse, Chair of Ecotoxicology and Environmental Risk Assessment at RWTH Aachen University. You'll typically find a dizzying mix of chemicals, pharmaceuticals, pesticides, industrial compounds, all coexisting. Backhouse recently co-authored a paper in Science proposing a new solution, the mixture allocation factor, MEF, a concept designed to make chemical oversight more realistic. Under this approach, regulators set a cap on how much of the total environmental risk any single chemical can consume. Think of it as dividing a shared risk cup. No chemical should fill the entire cup by itself. Instead, each gets a smaller fraction. Industrial chemicals, many already covered under REACH, would be the first group to face this method. Here's how it works. Chemical risk is usually calculated as a ratio between exposure and toxicity, producing what's called a risk quotient, RQ. The RQ must stay at or below 1, meaning a compound's concentration cannot exceed its safe limit. The MEF tweaks this rule. When considering mixtures, the total RQ from all chemicals cannot exceed 1, and each chemical's individual RQ must stay below a reduced value. For example, applying an MEF of 5 lowers every chemical's allowed RQ from 1 to 0.2. The data and formulas remain the same, only the threshold changes. This shift helps regulators see the bigger picture. Chemicals with minor impacts stay largely untouched, while attention focuses on risk drivers, the few substances contributing most to overall toxicity. That focus could make chemical surveillance faster and smarter without overhauling entire monitoring systems. According to Backhouse, what makes this idea powerful is its simplicity. It requires no new testing technologies and applies equally to protecting human health and natural ecosystems. Of course, the numbers differ. Your body doesn't contain the same compounds as a river, but the logic remains the same, he says. Still, not everyone is fully convinced. Cynthia Ryder from the U.S. National Institute of Environmental Health Sciences acknowledges the MEF is a sensible starting point, but warns that it may need fine-tuning. We won't know whether it's too strict or too lenient until we actually test and implement it, she told Chemistry World. Claus Svensson from the UK Centre for Ecology and Hydrology adds another challenge: deciding which chemicals belong in a mixture assessment. Substances like pesticides or pharmaceuticals are designed specifically to affect living tissues. Should they be given their own MEF category? That's where debate may heat up. Backhouse agrees refinements are inevitable as data accumulates, yet insists the time to start is now. Industrial chemicals are the biggest group. We can't wait for perfect science. Even if they're not always the most toxic, they're the most widespread. So here's the bigger question. Should regulators prioritize action even if the model isn't perfect, or keep waiting for more certainty while chemical mixtures continue to build up? That's where the real controversy begins. And perhaps where your opinion matters most. What do you think? Move forward now or hold back for better data?